Welcome. This video is CC-BY-NC. All right, welcome back, everybody. We are going to talk about radian measure. So we have a couple of ways of measuring the angle, and radian measure actually is going to be much more useful for us as a tool as we go higher and higher into mathematics. And in the calculus, we only use radian measure instead of degrees. And so the definition, the radian measure of an angle theta in standard position is the directed length of the intercepted arc on the unit circle. So in the unit circle, this is going to be the angle in radians. And what happens on the unit circle, the circumference, as we know, is 2 times pi times r. But when r is 1, the circumference is just 2 pi, which is also the angle. Right? That's the point. And we know for a circle, that's completely all the way around. This means that there are, in 360 degrees, there are 2 pi radians. So here's our conversion factor from degrees to radians. And if I divide both sides by 360, I get that 1 degree is 2 pi over 360, or pi over 180 radians. That's going to be our conversion factor, pi over 180. The other way is if I divide both sides by 2 pi, then I get that 1 radian is 360 degrees over 2 pi, which of course reduces to 180 degrees over pi. So here are our conversion factors that we will be using. When we're going back and forth between degrees and radians. All right, let's start with a nice simple example. We're going to convert negative 225 degrees into radians. Well, this means I'm going to take the negative 225 degrees and I'm going to multiply that times pi over 180. And I'm going to reduce that fraction. It's still going to be negative. So 225 and 180. 225 divided by 180. Let me show you a fancy trick with this calculator if you have one that's similar. If I don't want it in decimals like that, I can hit math and convert it to a fraction. And you will not be allowed to use decimals unless it says so. This means that it's negative 5 pi over 4. So there is the radian equivalent to 225 degrees. Kind of cool. So now we're going to go the other way. Now we are going to get decimals. And so for this one, we have 1.51 radians. And now we're going to go the other way. We're going to do 180 divided by pi. And this one is going to get messy. So 1.51 times pi. Times 180, pardon me, 180 divided by pi. That is 86. Point says to the nearest hundredth, 0.52 degrees. Example 3. 23 pi over 6 radians into degrees. 23 pi over 6 to degrees. So that is going to give me radians. So we need 180 divided by pi. And you can see the pi's reduce. So we have no need for a decimal at this point. But I'm going to do my reducing fraction trick. 23 times 180 divided by 6 is 690 degrees. All right. One more. So we're going to convert negative 219.25 degrees into radians. They tell us to round to the nearest hundredth, so we are going to be doing that. So degrees into radians, this is going to be times pi over 180. So negative, just a little bit, 219.25 times pi divided by 180. Yeah. That gives us a negative 3.8, and we'll say 3 since we're rounding it up, and that's radians. Now, we often don't put the label radian on it. It's common to not put that in. And we'll talk more about that in another lesson. All right. Graphing radian measure. So what we're going to do is we're going to go through and try to convert all of our common angles that we have into radians. And I'm going to go ahead and start marking this up. Use blue. So 0 degrees is 0 radians. That's easy. Now I could go through and show all of these, but I'm going to just write them in for us. So this is pi over 6, pi over 4, and pi over 3. Way up top here, that's pi over 2. That's 90 degrees. You'll get very familiar with these as you go. So this one is 2 pi over 3, 3 pi over 4, 5 pi over 6. And that's what parenthesis there. That is just. I'll show you where these patterns come from in just a second. The 210 is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. Down here, 270 is 3 pi over 2. Yep. 3 pi over 2. Here at 300, we have 5 pi over 3. Here we have 7 pi over 4. And we have 11 pi over 6. You will need to get familiar with these, like it or not. And I do want to show some patterns. Now, when we have a reference angle of 30 degrees, so here's 30 degrees. Here's a reference angle of 30 degrees. Notice they're both over 6. Reference angle of 30 degrees over 6. Reference angle of 30 degrees over 6. So anytime you see one that's over 6, we right away know what its reference angle is. It's 30 degrees or pi over 6. Same goes with the pi over 4. 45 degree reference angle. Here we have 135, also a 45 degree reference angle, 3 pi over 4. 5 pi over 4, 45 degree reference angle. 7 pi over 4, 45 degree reference angle. That means all the reference angles are 45 degrees or pi over 4 radians. Same with the pi over 3. Here's 60 degrees. Here's 2 pi over 3, 60 degree reference angle. 4 pi over 3, 60 degree reference angle. And 5 pi over 3 is a 60 degree reference angle. You can kind of view it like it's pi over 6, 2 pi over 6, which reduces. 3 pi over 6 is right here. 4 pi over 6 reduces. 5 pi over 6. So every 30 degrees, we're getting one. It's just it reduces to a different denominator. All right, so that's the bigger picture. And let's do some sketching and find some coterminal angles. So here we go. All right, we're going to sketch negative 2 pi over 3. Now, Negative means I'm going this way. Negative pi over 2 is down here, and 2 pi over 3 is larger than that. So that's actually a 60-degree reference angle because it's over 3. And let's do color. That's actually going to be this one here. Negative 2 pi over 3. Negative 11 pi over 6. If we use our circle up here, negative 11 pi over 6. Now notice 11 pi over 6, that's almost all the way around. So we're going to go all the way around to there. So pi over 6 is going to be there. And this is going this way. That's negative 11 pi over 6. We did it. All right, so now we want to find a coterminal angle. That's between 0 and 2 pi. That's like 0 to 360, right? Now, 12 pi over 6 is 2 pi. That's once all the way around. So 35 pi over 6, that's way too much. I'm looking for something less than 2, bigger than 1, bigger than 0, pardon me. So 35 over 6 minus 2. I'm not messing with the pi's right now. We'll put those in later. Minus 2. Change to a fraction. Still not less than 2. Let me subtract another 2. Oh, it did it for me. 11 over 6. That is less than 2. So that's going to be, this is coterminal. With 11 pi over 6. Negative 9 pi over 2. Again, that's way too small. And because it's negative, negative 9 divided by 2, I'm going to add a 2 now. Convert to a fraction. Still negative, so I'm going to add another 2. Still negative, I'm going to add another 2. It's like I'm adding 2 pi. And 3 pi over 2 is it. With 3 pi over 2. I know it's new. It's going to take some time to get used to these radians. They're a little weird, but hope that helps. We'll use them throughout the rest of the lessons.